Hi everyone. So in my last video, I talked about the multiple spanning tree protocol, and in this one, I made a mistake of telling that this will be the blocking port, which is wrong. This will be a designated port, and the alternate port. So this election happens based on the MAC address and the system ID. So based on that, the lower one is given the chance to be designated port. So if there are two links, so now based on that, it will choose whether which one is the more efficient one, and that will be given as a designated port to go through this link to the root bridge, and the alternate port is given to the other one. And for the alternate port, it is given the block state. So that was the mistake that I gave this one as blocking port, which is wrong. Now I'll talk about the spanning tree protocol configurations. So I will not be going through the complete topology, but just the configuration that is used to configure STP in a switch, an Nexus OS switch. So first we do is config conft, and then we can check whether we already have VLAN enabled or not, or configured or not. So first of all, the STV configuration is enabled by default. So we just need to configure it for different VLANs. So we just need to do is VLAN 2, 3 if we are doing for 2 and 3, and then we exit it, the conf, and then we just say that spanning tree, let's say for VLAN 2, and give some priority of 4096. So this is done to make like some like if it's done for NXOS switch 1, then this switch 1 will be given a priority of 4096 and it will become a root bridge. So this is what it is for, to make like election easier for the root bridge, and the priority based on priority. So this will be the least priority, which is 4096, and all the priorities are in the multiple of 4096, which with 4096 being the least. Now so we need to also do is we need to enable trunking on the port that is connecting to two switches. So how do we do that is we again go for conft configuration. Then let's say that one of the like we have two interfaces, so Ethernet 1 to 2, and then we say switch port, and then we say switch port mode trunk, then we say switch port trunk allowed VLAN 2 and 3, and then we do no shut. Okay, so this is made to make sure that the first that link between two switches is a trunking switch port. Okay, so this enables trunk port, and this allows which VLANs are allowed to use that trunk. And we can finally check the trunk ports and spanning tree, how it's going, using show spanning tree VLAN 2 if you want to see VLAN. So this will showcase what is the priority value and what is the designated port and everything. We can also check show run VLAN. So these are the main configurations. So this is for STP. Now we will do it for multiple spanning tree, where we not only have like one VLAN but multiple VLAN that we need to configure. So we start with conft, and here what we do is since we know that MST is an instant wise, so first we do is we enable MST. So spanning tree mode MST. Then we say spanning tree, and then MST 0, the 0 instance, and we say what will be the root, whether root will be a primary or secondary. Then we do the same thing for other instances. Let's say there are 3 instances in total. So root primary, and then similarly for this. So 3. Now we must configure the name and everything. So spanning tree MST configurations, then we put a name, let's say MST underscore exp, and then we do instance first for VLAN 2, then instance 2 for VLAN 3, and then we do revision 3. Okay, so what happens with this is that we need not consider the instance 0 because its default is VLAN 1. We do it for other instances and which VLAN we need to configure, and then we do the revision. Now we can check the spanning tree using show spanning tree MST configuration. So this is pretty much on the MST configuration side, and I'm just going to tell what configuration is required to configure a switch. But if you want to go through all the topology, you have to go through the like packet tracer or GNS3 to do that. Now let's talk about port channels. So for port channel, port channel is used as a link aggregation mechanism, and how it works is that like their logical links like that consist of one or more like physical member links. So that what it means is that there can be multiple links between two switches, let's say these two, and port channel does is it combines or amalgamates all the like physical links into one logical link. The port channel can be, and the port channel can be either layer 2 or layer 3. So it's just that we bundle all the physical links into one logical link or one interface. So that helps in sending packets or LACP, and like it will be load balancing it, and it will be more faster. There will be more resilience as well. So these are the reasons why we do it. So let's talk about LACP, which is the packet that is being transferred from from port channel from one switch to another. So it is used to detect connectivity between devices. So LACP has three types of messages. First is sync, second is collecting, and third is distributing. Now like yeah, before we talk about LACP, I forgot one thing, which is there are two configuration modes in port channels. One is on and the other is LACP. So we will talk about this LACP because of that, because this is preferred over on mode. Now there are three types of LACP messages. The first one is sync. What this does is it is an initial flag that indicates that the local switch will include the member interfaces as part of the port channel. So if the sync is 1, or it's just a flag, so if it's a 1, then it means that it will indicate that that local switch will be included in the member interface as part of this port channel. If it's 0, that it is not included yet. The collecting part is the second flag that indicates that the local switch will process network traffic that is received on this network. So sync will only be included, but it will not process. But when it's in the collecting phase, that or collecting messages, then it will also take the messages and it will process that message. And distributing, as mentioned, that it's another flag which will allow the local switch to transmit network traffic using this member interface. Now let's talk about LACP negotiation and how two switches negotiate or do the handshake and everything. So the first step is that both switches advertises the LACP packet with the sync, collecting and distributing flags all set to 0. So S, C and D all are set to 000 advertisers. Now in the second step, the source switch receives the LACP packet from the destination switch. It collects the system ID. So it collects system ID, port ID, information from the initial packet that is coming from the destination destination switch. So the source switch that then transmits a sync like LACP packet indicating that it will be willing to participate in this like port channel. So when it goes back and says that yeah, I'm willing to participate, then it sends sync as 1. Now sends from the source to the destination. So destination also do the same with sync 1, that it is willing to participate. The third step will be that initially the LACP packet include the local system ID, port ID and port priority along with the detected member information and everything. So it will send in the sync all this information, that what is my system ID, port ID and port priority. Based on that, the port channels and these other spanning tree protocols decide like which is the better method or root bridge or something like that. Now the third step is that the LACP member for the port channel have been selected at this time. So now based on sync, the complete topology, they will be decided that yeah, these are the switches that are participating in the LACP membership. And now the fourth step is that upon the receiving of the LACP packet, the source switch verifies that the local and remote matches the single LACP packet to ensure that the switch ID is the same across all the members link. So what it means is that the source switch will get all the LACP packets of different system IDs and everything, and it tries to match the sync LACP packet to ensure that their own switch ID and everything is matching with the LACP packet that it's receiving. So based on that, it will understand that whether everything is in the verified part or not. If it's not, then it will throw the error. Now source switch then transmit a collecting then it starts with the collecting, where it says that yeah, I'm collecting the data. So then transmit a collecting LACP packet that indicates that the source switch is ready to receive traffic on that interface. Now the sixth step will be similarly the destination packet also verifies the accuracy of the sync packet for the source switch as what was performed by the source switch. The destination switch then sends a collecting packet that indicates that the destination packet is also ready to receive traffic on that interface. So both sides. So the switch is there, and from both sides it will say that yes, I am ready to collect data, and I'll be ready to, because I have verified the data and I'm pretty much that it's correct. So now it will start collecting the data as a member. Now in the sixth step, the source switch receives the collecting LACP packet from destination switch and then transmits the distributing packet. to the destination switch. Now it says that like I am transmitting the membership link, members link through members link, the data. Now, seventh step will be the destination switch receives the collecting LACP packet from the source switch and transmits the distributing packet, which is the flag set with the distributing flag, to the source switch to tell you that it is transmitting data across that multiple link. So it starts with the both ways, where both switches sends its own distributing packet to say that I am transmitting now the data, and once all these messages are exchanged, the traffic is then forwarded on the LACP link. Now everything is done and all flags are set to 1. Then it will start to forward LACP negotiated link of the port channels. So that is pretty much what the LACP packet works, how LACP packet works for port channels. Now, in general, the LACP takes around 30 seconds to send LACP packets, which is kind of very slow. So for that, a new concept was generated, which was LACP fast, which sends the data or the packet in 1 second. And it is enabled using LACP rate fast, and it can be configured to any seconds. So this is configurable. Now, so once the LACP matching happens, there are multiple things that is needed to be taken care of, and these should be matching so that membership can be established between LACPs, between switches. So one is port type, port mode, native VLAN, allowed VLAN, speed, duplexity, maximum transmission unit, load interval, and storm control. Similarly, we know that port channel are used for traffic load balancing. So for traffic load balancing, so it uses a hash command to do the load balancing, and hash commands have various options like destination IP, destination MAC, destination port, then source, destination IP, source, destination IP only, source destination MAC, source destination port, source destination port only, then source IP, source MAC, and then source port. So these are used to do the load balancing. That is pretty much it what